All right, so for the second video, I just want to run a couple examples where if we're sort of given some of these different figures, just doing a quick calculation for both the area and the perimeter. So nothing too wild. We'll start with the one in the book, example 2.1. This is just a nice rectangle. We're thinking something like the square is so straightforward, we're not even going to run an example. So we'll do a rectangle. Of course, you could use rectangle techniques to find perimeter and area for a square. The one thing I'll sort of add on to this picture, you can see in this case we've got a rectangle that is 14.4 inches by 3.53 inches. Very precise measurements here. The one thing we can add on just for sort of completeness sake is in theory you could kind of label the opposite sides, the sort of opposite length and the opposite width. So if this is 14.4 inches, this is also 14.4. If this is 3.53 inches, this is also 3.53 inches. So just to kind of complete all four of the sides, we'll use all four when we find the perimeter. In this case, we're just doing the area first, which would be our sort of length times width. Which is the length and which is the width. Honestly, in this case, it's arbitrary. If we're sort of following the example here, it looks like we're saying, right, our sort of value here is the length, and our value here is the width. Again, it doesn't particularly matter, right? If you flip this on its side, then I guess the perspective changes. It's arbitrary. So all we're doing here, this is really a calculator problem, just a quick multiplication, 14.4 times 3.53. If I take my calculator out, let's see if I can do this. What did I just say? 14.4 times 3.53. Boop. So I'm getting 50.832, and that's what I've got here. Right, so just a quick calculator problem. The one thing here to sort of keep in mind is you need to watch your units, right? So your area is inches times inches, which means you're going to get inches squared as your unit coming out. Versus the next one, which is perimeter, where you're only going to have inches because it's just adding up inches plus inches plus inches. Speaking of the next one, so my perimeter, either one of two ways, right? What we're doing here is sort of like we have the formula. You can sort of do the length plus width and then just multiply them by 2. The big thing here, right, is you're just trying to sort of get 2 of the lengths and 2 of the W's, right? So you could also do 2 times L plus 2 times W. Either of those is totally fine. In this case, if we kind of add these guys up, 14.4 plus 3.53, so that's a 17.93. The units here, right, are only inches because if you're doing perimeter, you're just adding inches to inches, which just means you get more inches, right? And then from there, you're multiplying by 2. So my final value here, 35.86. Again, that's just going to be inches. So that's area and perimeter for a rectangle. I drew a couple other figures. Let's sort of take a minute, let's do a triangle together, and then we'll also do a trapezoid. So I drew sort of a sideways triangle. In this case, we've got all 3 sides labeled. Obviously, we need that for the perimeter. Why don't we do that first, I guess, just because it's right there. So my perimeter is just going to be, right, add all 3 sides. So that's going to be 6.9 plus 9 plus 7.5. I didn't put units on here, I guess, just to sort of save a little space. I'm sort of, I didn't draw these super big. Try to keep everything in focus. So what did we just say? 6.9. This is probably not so wild. We couldn't, in theory, do it in our heads. But just to demonstrate some good calculator business, 6.9 plus 9 plus 7.5 is 23.4. So that'll be my perimeter. So we'll mark it. So not even really a whole lot to think about there, right? We're essentially just saying, okay, let's just add these 3 numbers together. So as long as you can kind of get them into your calculator in the right order with the right operation, you should be good to go. My area value, right, for a triangle is supposed to be 1/2 base times height. Now, what's the base here? What's the height? What's going on? This triangle is sort of like pointed out. towards the right. What I'm going to do, it looks like the sort of flat edge is here. So I'm going to call that my base. And then I'm kind of given, in this case, right, this sort of piece coming from this sort of peak, this kind of right-handed peak coming down is going to get me 6.7. So that 6.7 is going to be the height. So this is all about kind of keeping yourself oriented. So my base value here, we said 7.5 times my height, which is 6.7. And that whole thing is times 1/2. Now, you could think of that as multiplying by 1 and dividing by 2. That's a little redundant, right? You could sort of just think of it as dividing by 2. Or you could just use your decimal and multiply by 0.5. Let's crunch these numbers. Try to keep everything in frame. Good enough. So what did we just say? I'll do 7.5 times 6.7. So that gets me this. I'll divide by 2. Looks like 23.45. Now you might say, Professor Johansson, that seems extremely close to the perimeter that we just found. And I would say that does seem pretty close to the perimeter we just found. That is totally a fluke. That is not necessarily what you would expect. It's just a fluke based on these numbers. In theory, right, this would sort of be units squared, and my perimeter would just be sort of regular units. I'll kind of mark them with dummy units for now. If I wanted to do one more figure as another example, so let's take a trapezoid. Trapezoid is where we have maybe the most just like lengths to sort of keep track of in some sense. If we do a little bit of quick labeling, again, you want those parallel sides to sort of be your different base values. So maybe this is base 1 and this is base 2. And then the 12 here is going to be your height value, right? So that's directly from the top to the bottom. We're really sort of ignoring, at least as far as the area goes, we're sort of ignoring the diagonals. I guess in some sense we did our perimeter first in the last one, so maybe I should do that first again here. Perimeter, we're just going to add up all the 4 sides. 20 plus 12.6 plus 30 plus 13.4. I'm not sure if I just said this right, but when you're doing the perimeter, you're not doing anything with the height value, right? That height value is an interior length. Perimeter is only values from the outside edge, right? Is only from the outside. If I crunch these numbers, what did we say? 20 plus 12.6 plus 30 plus 13.4, 76. 76 right on the nose. So our perimeter here is going to be 76 units. Good to go. Makes sense, I guess. 0.6 and 0.4 would sort of add to a whole number 1. And then what was our area formula for the trapezoid? Excuse me. You, of course, you remember it was 1/2 the quantity, right? Base 1 plus base 2. So you have the base values added together times 1/2 and then times the height. So if we sub our values in here, base 1, right, 20 plus base 2 is 30 times my height value, which is 12. Oh, this is actually going to be the nicest numbers we had so far, right? Because 20 and 30 is, of course, 50. 1/2 times 50 times 12. This would be essentially like, well, 1/2 times 12 would be 6. 6 times 5 is 30, so 6 times 50 must be 300 units squared. So area values, right? So area is always going to be squared units. So that's what we've got there. So a couple different things, right? You know, these maybe seem a little bit boring, a little bit straightforward. What we're going to do that's a little bit more interesting next is look at some compound figures, and we actually sort of start to mix and match these different shapes together. But to do those values, to solve those problems, we're going to have to be sort of using all these different formulas. So as always, we want to make sure we can sort of walk before we run. We want to make sure we know how to use these formulas before we try to do anything more advanced. All right, see you in the next video.